Hello, welcome back. Today let's try to solve another Leetcode problem, 931, minimum folding part sum. I've already solved the minimum folding part sum 2, but today let's try to solve number 1. Actually, it should be much easier than part sum 2, but actually this part sum is much easier because this is just a matrix problem. It is a DP matrix problem. Now let me first go to the whiteboard to explain my solution and then go to the code editor to finish the coding because this is just so easy to understand. Yeah, because there are just for the next row it will be row plus 1 and for the column it will be column minus 1 plus 1 and this column. So it means for example this number 1. So for the next row we're going to choose 6, 5 or 4. It's going to be the minimum. So for the next we're going to choose this number 4 or number 5. If we choose number 4 for the next one, we can only choose 8 or 9, but we're going to choose 8. If we choose number 5 for the next one, we're going to choose this number 7 because 7 is the minimum compared to 8 and 9. So our final result is 13, no matter which path we choose. Now let me go to the whiteboard to explain my solution. Because this is just a DP problem, we need to update the state. It is a top-down DP problem. We can directly do it from the top to the bottom because we just need to calculate. So this is our first state, 2, 1, and 3. So our next state is for this 6. So 6 will be compared with 2 and 1. So what it will 1 because 1 is minimum. Yeah, and for this 5, which number it going to choose? It's going to choose 1 because 1 is the minimum. Yeah, as you can see, if it is at the border, 6 normally need to choose two numbers here, this number, 2 and 1. But there's no number, so this is the border. The border is from the 6 and 2. We cannot choose another number. This means we can use some paddings to make our calculation easier for the DP matrix. Now we just need to do some padding. Let's do a padding. Let's prepare a padding here. And let's prepare another padding here. Yeah. Why? Because we need the calculations. And inside the paddings, it should be the minimum. Why? Because if we're gonna choose this 6, normally we're gonna choose the 3 numbers, this one, and this one. But this infinite doesn't influence our any calculation because basically we just need to choose this number 1 because the infinite is always be the maximum, but we need to calculate the minimum. And similarly, we need also prepare the paddings from the right side. So let me prepare this padding to the right side. So we're gonna prepare also 3 paddings to the right side because only in this way can we solve the problem easier. Now let me prepare another 2 paddings. So after preparing all this, we can solve the problem easier. So this is our new DP array. And our matrix is still this 2, 1, 3, 6, 5, 4, 7, 8, 9. Yeah, so from the beginning, our DP array, it is always be the 2, 1, and 3. So first of all, we're going to prepare this 2, 1, and 3 inside our DP matrix. So currently, this is our DP matrix. And inside these areas, we have not calculated yet, but we've already prepared for our DP array because we're going to start from the second row. So from the left side and the right side, it will be infinite because this is just for padding. It will not influence our result, just easy for the calculation. And for the first row, we will prepare the 2, 1, and 3 because this will not change. Now we are going to start from the second row. So for the 6, it's going to choose 3 numbers. So it will be updated to 7 because 1 is the minimum. And for this 5, it's going to be updated to 6 because 1 is the minimum. We can only choose 2, 1, and 3. So this is going to be 6. And for this 4, it's going to choose this 1 because this 1 is the minimum compared with the 3. And it will be the 5. Now we are going to update the last row. So what's going to happen? 7 can choose 7 or 6. It's going to choose 6. So here will be 13. And for this 8, it can choose 3 numbers. It's going to choose this 5. So it's going to be 13. And for 9, it can choose 6 and 5. It's gonna choose 5 because 5 is the minimum. So here will be 14. So our final result is 13. It can either from one path to here 13. It can also from another path. Yeah, I forgot the path, but you know it. There's another path goes to 13. So our final result is our dp minus 1. This is the last row. So it is the minimum of this dp minus 1. So this is our final result. Now let me go to the code editor to finish the coding. So this is some some strategy or technique we should use for the DP matrix. Normally we can use padding from the top, bottom, left, or right. But for this problem, we can make it easier to solve it using the paddings left and right, use infinite numbers. Now let me go to the code editor to finish the coding. Yeah, let's compare it with the image with my coding. Yeah, because this will be easier to understand while coding and while checking the images. Now for the DP array, I'm going to prepare my DP array. But before that, I'm going to create a row and column. So for the row, it will be length of the matrix. And for the column, because I need to prepare a padding, so it will be the length of the matrix 0 plus 2, because inside it will be the infinite. Now I'm going to prepare my DP array. So DP array inside it will be infinite and times the column, and for R in range how many rows I have, because this is just for the column. Yeah, I prepared some paddings, one padding at the left and another padding at the right side. So this is basically my DP array. But for the rows, I didn't prepare any padding because it doesn't matter. Now I'm going to update the first row first. Yeah, now it will be for say in range, it will gonna start from the index 1, because the first one, the 0 is infinite. So I'm going to put it 2, 1, 3 inside my DP array. So it will be 1 to say minus 1. Yeah, because at the right side there's also a padding. At the left side there's also one padding. We just don't need to do that. It's gonna be infinite. But except that in the middle it will be 2, 1, and 3, exactly like this for the first rows of my DP array. So the DP array, it will be DP the row 0 and column C should equal to the matrix 0. And here we need to take care, because this is C starting from 1, but for our matrix is starting from 0. So it will be C minus 1. So up to here, we finished the update of the first row. Now we are going to start from the second row. So for R in range, but for the rows, we're gonna start from the second row. It means it will be 1 and 2 R to our last row. And what about the column? So for say in range, the column should also start from 1 to C minus 1. Yeah, because we don't need to calculate the padding. The padding doesn't matter. So this 1 to C minus 1, it is in the middle between 6, 5, 4, these areas. We didn't include the padding. The padding is just used for calculation. So now we can do our calculations. So we're gonna update one by one. So for the DP, R and C should equal to the minimum of DP, the row before. So this is our current row. So the row before it, it is R minus 1. And what about the column? The column, it will be C minus 1, because if we are at this place in the column C, C minus 1 is here, up to C plus 2. because C+2 is not included, but C+1 is included. This means the column will be C minus 1, C, and C plus 1. So here C minus 1, C, and C plus 1 until we go to C plus 2, but C plus 2 is not included. Now we are going to plus the matrix value. For example, this value is 6. So the matrix R gonna, let's check the matrix R gonna be, so here it is the second row, so R will not change, but for the column it's gonna change. So here the column start from index 1, but for the matrix for this 6 it's gonna start from index 0. So this means here for the column it should be C minus 1. C minus 1 is used for the padding because we prepared a padding. So for the matrix inside, it will be C minus 1. So this is something we need to take care if we prepare a padding at the left and the right. So normally, up to now, it should be okay. Now let me return the final result. So the final result should be the minimum of dp minus 1. So this is our final result after we calculated to this one. Because the infinite doesn't matter, we gotta calculate the minimum. So this infinite and this infinite doesn't matter. So this is why we needed to prepare the infinite, because we are going to calculate the minimum. Now let me run it to check if my program works or if there are any mistakes. I hope there are no mistakes. Yeah, it works. Now let me submit it to check if it can pass all the testing cases. And by the way, the time complexity is O(n) squared because we used 2 for loops. And the space complexity is O(n) squared because we prepared our DP array. As you can see, it's pretty fast. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.